Welcome back to Math 103. This is video number 27 on growth and finance. Someone you know borrows $250 at the end of each quarter from a lender with an APR of 20% compounded quarterly, and it keeps borrowing, that is, borrows a new $250 every quarter without paying anything back yet. What's the total amount which your friend owes at the end of one whole year, at the end of 4 quarters of borrowing and accumulating interest on this debt? Your friend's total debt at the end of 1 year can be written as a sum in the same way it would if we were talking about saving $250 in a savings account every quarter. As usual, we focus on the first $250 and see what happens to it. So instead of $250 going into a bank account and earning interest several times, you are borrowing, your friend is borrowing, you wouldn't do this, your friend is borrowing $250, and it is accumulating interest charges several times through the year. 3 times during the year in particular, because this $250, the first $250 is borrowed at the end of the first quarter. Think of the end of the first quarter as the end of March. That means at the end of June, the end of September, and the end of December, there are separate interest charges. That's what it means that the interest is compounded quarterly. This lender charges your friend new interest every quarter. How much interest? Well, 20% is a full year's worth of interest. Therefore, a quarter of that is 5%, is a quarter's worth of interest. So every quarter, however much your friend owes, is multiplied by 1.05, the quarterly growth factor. That first $250 loan at the end of March, that accumulates interest 3 separate times. So it's multiplied by 1.05 3 separate times over the course of the year. The next $250 that your friend borrows at the end of June accumulates interest at the end of September and again at the end of December, only twice. The $250 borrowed at the end of September only accumulates interest charges once at the end of December, and the very last $250 borrowed at the end of December has had no time to accrue interest charges. So what do we know about this transaction? It involves regular payments of $250. Your friend is receiving the $250, but they are payments nonetheless. There is a periodic interest rate of 5%. Within each time period, the interest rate is 5%. It's 5% per quarter. And how many payments are there? There are 1, 2, 3, 4 of them. This analysis gives us everything we need to know in order to apply our favorite formula. We have $250 to plug in for PMT. 0.05 is the quarterly interest rate expressed as a decimal. We plug that in for I, and there are 4 payments. We plug that in for N. We compute the value of this expression, and it turns out to be $1,077.53. That is your friend's total debt at the end of 1 year. This number is plausible. If the interest rate were 0, your friend would owe $250 times 4, would be $1,000. But the interest rate is greater than 0, so your friend actually owes more than just the $1,000. We can go on to ask, how much will your friend owe at the end of 6 years? Well, after 6 years, there will have been 24 quarters of acquiring a new $250 in debt each quarter. Right? So this is still an annuity. This is still a transaction in which the same dollar amount, $250, changes hands regularly every quarter. And this happens 24 times. So we get a long sum that starts with $250 times 1.05 to the 23, remember 1 less than the total number of payments, and ends up with $250 times 1.05 to the 0. Okay. The only thing that's different from the previous problem is just the value of n, which is now 24 instead of 6. Now we substitute our known values into the formula and compute. And it turns out, after plugging in and computing, that your friend will owe $11,125.50. Now let's think about that for a moment. Your friend borrowed $250 times 4 equals $1,000 in the first year. So $1,000 a year times 6 years is a total of $6,000 that actually made it to your friend's pockets. But your friend will owe $11,125.50. So your friend ends up owing much more than the $6,000 originally borrowed. Okay. So your friend's debt after 6 years of borrowing and not repaying anything along the way, just letting the debt pile up and pile up, is much more than 6 times the debt after 1 year. Right? After 1 year, you recall, the debt was only a little over $1,000. Now this makes sense because your friend enters each new year already in debt and then takes on new debt while the old debt continues to grow. So as long as your friend is in debt and time is passing, that debt keeps getting multiplied by 1.05 each quarter. That debt keeps accumulating new interest charges. What's the moral of the story? Don't be in debt. And if you're in debt, get out of debt. We remarked that the total amount of money that your friend is actually receiving over those 6 years of borrowing $250 a quarter is a total of $6,000. What if, instead of taking out these small $250 loans every quarter, your friend just borrowed the whole $6,000 up front at the same time as that first little loan would have been, namely at the end of the first quarter? Right? But then just lets the debt accumulate until the end of 6 years without any new borrowing or any paying back of the loan along the way. So a one-time $6,000 loan. Again, we'll assume quarterly compounding and a 20% APR. What will be the total amount owed at the end of 6 years? Now we have to be careful. We've been doing so many of these annuity problems, we have to stop and ask, wait a minute, is this really an annuity? Is it a job for the annuity formula? No, it is not. This is a one-time transaction. There are not many payments along the way. There is just this one $6,000 changing hands in one moment in time. Therefore, this is a job for the ordinary compound interest formula. That is to say, the $6,000 of debt will grow by a factor of 1.05 23 separate times. And that grows into $29,372.76. Right? If we write out this transaction as a sum of separate terms, this is the only term. There are no lower terms. There are no later transactions. This is the only transaction. Right? So this is just a single application of the compound interest formula, and lo and behold, your friend would owe quite a lot more, over $29,000 instead of a little over $11,000, by borrowing everything up front and being in debt this full amount the whole time, instead of gradually adding to the debt over time. Thus far, we've said nothing at all about paying loans back, making loan payments at regular intervals. That's going to be our next topic.